Today we will be working with inequalities, and we will be solving the equation 2x squared plus 9x is greater than 0. To first solve this, we have to notice that both terms, 2x squared and 9x, have an x in them, so we can factor that out. And we will be rewriting as if it's equal to 0, just to solve it. So we will have x times 2x plus 9 equals 0. Now we know we can solve this by setting the two terms, the first term of x and the second 2x plus 9, individually equal to 0. So for the first, x equals 0. And for the second, 2x plus 9 equals 0. So here we can solve the second by subtracting 9 from both sides. We will have 2x is equal to negative 9, and divide both sides by 2. So x is equal to negative 4.5. 4.5 being negative 9 over 2. So, our two solutions, x equals 0, x equals negative 4.5. If we put these on a number line, we will want to, for the inequality, solve for each interval. So we'll want to find a point here, here, and here to use as test points to plug back into our original equation. We'll want to use even numbers or whole numbers, integers, to make the calculation easier. So here we'll just use negative 1, 1, and we'll say negative 5. So to individually plug these test points, where the x's, back into the original equation, which was, for your reference, here, we just need to plug these values in. So 2, negative 5 squared plus 9 times negative 5, and negative 5 squared is 25, times 2 is 50, and then 9 times negative 5 is negative 45. That will be positive 5. And 5 is greater than 0. If we notice how that refers back to the original equation. So this would be a good area here. Now we'll plug in negative 1. So 2 times negative 1 squared plus 9 times negative 1. Negative 1 squared is 1, times 2 is 2. 9 times negative 1 is negative 9, so this equals negative 7. If we'll notice that negative 7 is not greater than 0, so that's not a good interval to use. Now for positive 1, we'll do the same. 2 times 1 squared plus 9 times 1. What does this equal? 1 squared is 1 times 2 plus 9 times 1 is 11. And 11 is greater than 0, so that region is also good. From this, we can surmise, as we have our two zeros, and we found what interval does not work, we can then we've proven that the outside intervals do work. Any value that is less than negative 4.5, and any value that is greater than 0. So our solution, our intervals of solution, are from negative infinity, that's with an open parentheses, to negative 4.5, also with an open parentheses, because the original solution said it had to be greater than greater than 0, and 4.5 was equal to 0. And then we union this from 0, which is our next solution, to positive infinity. And that is our solution.